We use electricity every day. It's ubiquitous. Where electricity is found, magnetism is often present, and vice versa. They produce an interesting effect called electrostatic shielding. Firstly, let's think how we can avoid certain death when encountering lightning. Of these methods, which is the safest? 1. Hide under an umbrella while praying to your deity of choice. Please don't hit me. 2. Find a scapegoat. Namely, stand next to someone taller than you. 3. Hide under a tree, so lightning hits the tree first instead of you. 4. Hide inside a car and don't come out. Which should you choose? That's right. Hide inside the car and don't come out is the safest option. There's an experiment where people sat inside a car and a lightning environment was created. The machine then discharges electricity at the car. From this picture, we see the people inside are safe and sound. This experiment shows that during lightning, hiding in a car is the safest. But what's the reasoning behind this? To understand this, we first introduce a fundamental property of electricity, that it can be positive or negative. If two things carry the same type of charge, they repel. But if they carry opposite charges, they attract. Now that we know this, let's think about the aforementioned question of why it's safe to hide in a car during lightning. We introduce a phenomenon known as electrostatic shielding. Imagine here a metal cage. When negative charges come near, the cage experiences a change in the electric potential on the outside. It then redistributes its positive and negative charges to counter this. In short, the electric field on the outside does not affect the region inside the cage. This effect of electrostatic shielding explains why hiding inside a car is safe. Let's see if we can find other examples of this in our daily lives. Everyone has this experience, where during a phone call, you walk into an elevator. The phone call then cuts off, and the other party thinks you hang up. From this example, we see electrostatic shielding not only isolate electricity, but also electromagnetic waves. This principle is also applied to induction stoves. The inside of the stove is heated, but people standing near it are unaffected, thanks to electrostatic shielding. Here's a photo of the Bird's Nest, a stadium used in the 2008 Beijing Olympics. Using the idea of electrostatic shielding, its metallic exterior is purposely designed to safeguard the tens of thousands of audience inside, even if the building is struck by lightning. This concludes our presentation. Thanks for watching!